The major evolutionary advantage we have as humans is this big brain on the top of our bodies, but it doesn't come with a user's manual.
Every thought you have comes down to 3 pounds of tissue sitting inside your skull.
It can consume up to 25% of the body's energy. So just imagine the amount of work that it does.
The nervous system is responsible for sensation, perception, feelings, thoughts, and behaviors.
But it's also fragile.
In your brain, there's a balance. When we experience pleasure, the balance tips one way. When we experience pain, it tips the other.
There's nothing as protective against addiction as a strong personal spirituality. Can we watch that in the scanner?
In this special episode, top experts break it all down by breaking down our brain and how it really works. This is me and Dr. Andrew Huberman. Maybe we could start with, how you think about the brain specifically. Like, what is the brain? What does it do? What does it not do? It helps us survive. It's our portal into trying to make sense of the world. Like, what's the starting point in the discussion around the brain?
Yeah, so the brain and nervous system, so it's like brain, spinal cord, connections with the body and back again. I don't distinguish between brain and mind. I think that's like an 80s discussion or earlier. And I think it would take us down the wrong track. So brain or mind to me is interchangeable. Mind-body is kind of interchangeable because the brain is connected to the body and the body's connected to the brain, right? If I, pinprick my hand and it hurts, my brain registers it, where it happens. It's kind of an irrelevant discussion now. I think we really need to just appreciate that the nervous system is designed to orchestrate all the processes in the body, not just thinking and not just behavior, and really can be divided into 5 things. So there's sensation, and sensation is really bound or restricted by the receptors in the body. So receptors in the eye that perceive photons, light energy, receptors in the skin that perceive pressure, touch receptors, smell, taste, hearing, etc. And the interesting thing about sensation and the fact that the nervous system needs to pay attention to sensation is it's non-negotiable. The nervous system of humans is designed to extract physical phenomenon from the universe that are non-negotiable, photons of light. I can't see in the infrared with my eyes, and I can't see ultraviolet light with my eyes. I can't perceive that because I don't have the receptors for it. So other animals can perceive some of those things, but that leads us to the next thing, which is perception, which is which sensations are you paying attention to? So all the time you're sensing things. Like right now, your feet are sensing the contact with your shoes, but you're not thinking about it until I say that. And then you shift your perception. Right. So perception is like this spotlight. So the brain wants to constantly bring in sensation. It's non-negotiable what's coming in. It's just dependent on your environment. Perception is negotiable. You can control that because I just said shoes and you thought about your feet and there you are. Then there are feelings, which can be a little bit nebulous, but feelings are a link between our emotion and it generally invokes the body, sensations in the body and concepts in the mind of what those sensations are about. That's really what emotions are. Animals definitely experience them. I'm kind of appalled to think that 10 years ago, people were like, do animals have emotions? Of course they have emotions, right? Because those are bodily sensations merged with some perception. So of course they do. And then there's thoughts. And thoughts are interesting because thoughts happen spontaneously. Think about like a web browser that's constantly giving you pop-ups. But thoughts can also be deliberate. So you and I can decide right now that we're going to think about a plan for something, or we're going to think about what's going on in the world. So thoughts happen spontaneously and they can be deliberate. And then the final thing is behaviors and actions. So the nervous system is responsible for sensation, perception, feelings, thoughts, and behaviors. And what's interesting, you start to think about that as you're like, okay, that's a lot. But what is the nervous system really trying to accomplish? Like on any given day or at any moment, what's it trying to accomplish? And it's really trying to accomplish one thing, which is to take perceptions of the outside world and merge those with perceptions of the inside world, what we call interoception, and to link those in a way that's operating on our environment in the appropriate way. So what do I mean by that? So if I'm feeling anxious and I'm in a very calm environment, I'm going to perceive that rapid heart rate and kind of feeling of agitation in my body as inappropriate for the moment, right? And my goal then as an organism is to adjust my level of what they call autonomic arousal or alertness down. If I'm at a great party or I'm at a wedding or it's a celebration or I'm at a protest or, then I might feel that my level of alertness is appropriate for my environment. So the nervous system is in this constant dynamic interaction with the outside world and trying to figure that out. One way that this can be kind of conceptualized is there's an emerging idea that's kind of interesting about impatience. So we've all had the feeling of being impatient. Some people are far more patient than others. But if you've ever been in line at the store and you feel like something's going very slowly, the person in front of you is taking a long time, they're doing some returns, and you're getting kind of impatient, maybe you're breathing in a mask, and you're like, ugh, like what's the idea is that if you're getting a certain frequency of pulses from your body, and if those pulses are coming in quickly, like you're perceiving yourself, that interoception quickly, it's like pulse, 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 pulse. You're going to be more geared towards your internal representation. And then you're seeing what's going on in the outside world, and it seems like it's going very slowly. But there are other times when you're in line at the store, someone's getting some returns and you're texting on your phone, or you've had a great day, you've had a great run, your family's in great shape, and you're fine. Why? Well, the frequency of those pulses, that interoception, is matched pretty well to your outside environment. And so impatience is really when your internal sort of metronome, tick, 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 is not matched well to the external environment. There are other times when you're feeling like your internal metronome is tick, 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 and you've got a million things coming at you through email or text, and you've got a bunch of things, and you're feeling overwhelmed and tired. Well, in either case, there's nothing right or wrong. It's just your body and your brain are trying to say, what's going on in the outside world and how well matched am I to it?
Right.
So if you think about some of the sort of core practices of mindfulness and self-regulation, of like focusing on breathing or focusing on state of mind, a lot of that is trying to bring more awareness to your internal state. But what our brain is normally doing when our eyes are open and we're interacting in the world is we're constantly trying to update our internal state to match external demands of the world. And this harkens back to a really early design of all nervous systems, which is how do you take an organism that needs certain things, food, water, mates, reproduction, shelter, how do you move that organism? How do you create a system that will do that in best relation to the environment? And so what Mother Nature has done is designed a series of systems. Let's just take agitation and stress for one. If an animal or a human is very thirsty, you feel kind of agitated, you might get up and get a drink of water. If you're very thirsty, it can put you into a state of panic. If you're extremely thirsty and water is a limited resource, you might even resort to violence to get it, or negotiation of some sort that you wouldn't if you were calmer. So that stress and agitation were designed to actually mobilize the body to take us in the direction of something that's adaptive. So you can start to see these kind of core elements of what the brain and nervous system do: sensation, perception, feeling, thought, and action. And this constant challenge of trying to match our internal state to the external real estate, the outside world. And you start to see that the sensations that we call stress or impatience or calm are really the result of those attempts that the nervous system is trying to perform.
That's a lot to take in and super interesting. And it it's prompting in me this attempt to try to wrap my head around what within the brain is mutable, which is kind of, what your work is all about, versus what is immutable. Like you were talking about thoughts like pop-up windows on a browser. Sometimes our brains are just doing what they do, and that there are things that we can do, like mindfulness and breath work and the practices that you're talking about, hypnosis, which is another thing that you're, involved in, to help us like manage better that process, to kind of take the reins and be more in charge rather than be prey or victim to these kind of things that just occur without our conscious awareness.
Mm-hmm. Well, I think that, in terms of value of understanding the nervous system and where it can be steered, it's absolutely clear that the nervous system can change in response to experience. So this thing we call neuroplasticity is really that. It's the brain's ability to modify itself in response to experience. And I think it's important to understand that from birth till about age 25, the brain is extremely malleable in a kind of almost passive way where kids are exposed to things and the brain is just wiring up. I mean, the brain is really designed to adjust itself in order to be in concert with its surroundings. And to optimize that, just the way we described it a minute
Like
ago.
a way that a child can learn a language very quickly, or
3 languages.
play the guitar or something.
Yeah,
like that.
without an accent. 3 languages without an accent. It's remarkable. You try and do that after age 25. It's very challenging. And so the brain is basically designed to be customized in the early part of life, and then to implement those algorithms and that circuitry for the rest of its life. And so the brain can change in adulthood, and it can change provided that there's an emphasis on some perceptual event. So in other words, if you want to change your brain as an adult, let's say you want to be less anxious, you want to learn a new language, you want to be more functional in some way, presumably. The key thing is to bring focus to some particular perception of something that's happening during the learning process. And the reason for that is that there's a neurochemical system involving acetylcholine. And it comes from these 2 little nuclei down in the base of the brain called nucleus basalis. All day long, you're doing things in a reflexive way. But when you do something and you think about it very intensely, acetylcholine is released from basalis at the precise neurons that were involved in that behavior, and it marks those for change during sleep or during deep rest later. So for people that want to change their brain, the power of focus is really the entry point. And the ability to access deep rest and sleep. Because most people don't realize this, but neuroplasticity is triggered by intense focus. But neuroplasticity occurs during deep sleep and rest. And we can talk about how to optimize those different brain functions. One of the things that's really important also to think about how the brain works in terms of plasticity and all this stuff is what the brain really wants to do is also pass as much of what it does off to reflexive behavior as possible. So, so when we're talking about focus, I think it can get a little bit vague, but it might be useful to think about like what exactly is focus and what triggers plasticity. So the brain loves to be able to just do things, pick up coffee cups and drink and walk and talk and do things and not put much energy into it. When we decide to focus, what the brain really does is it switches on a set of circuits that involve the frontal cortex and nucleus basalis and some others, and it's trying to understand duration, how long something's going to last, path, what's going to happen, and outcome, what ultimately is going to happen. So duration, path, and outcome. The events of early 2020 are a good example of this. One of the reasons why it's so exhausting to be alive in 2020 is because we are now having to pay attention to duration, path, and outcome. How long is this thing going to last? When are they going to open up all businesses? Did I touch that door handle? Does it matter?
Right.
Who are the experts? Are there any experts? There are a lot of questions, whereas normally we can just move through life without having to do all that analysis. So if it's a simple example, like trying to learn a new language or a new motor skill or a new way of conceptualizing something, maybe somebody's in a therapeutic process and they're trying to work through a trauma or something like that, duration, path, and outcome is built into the networks of the brain. We can do that very easily, but it takes work. And it almost has a feeling of underlying agitation and frustration. And that's because the circuits that turn on before acetylcholine are of the stress system. So when you or I decide we're going to learn something and really dig in, norepinephrine, which is adrenaline, is secreted in the brainstem and in the body, and it brings about a state of alertness. Then our attention, which is mostly a diffuse light, is brought to a particular duration, path, and outcome analysis. This would be thinking about what somebody is saying. What are they really trying to say? A hard passage of reading, a hard set of math problems, a challenging physical workout. When you do that, these two systems have to work very hard, and the adult brain doesn't really want to change the algorithms it learned in childhood. But if you do those two things, you have alertness and focus. The acetylcholine and the norepinephrine converge to mark those synapses for change. And so the way to think about neuroplasticity, if one wants to change their brain, is bring about the most intense concentration you can to something, and then later bring about the least amount of concentration of that thing. So I'll talk about that in a second, but there were some studies that were done at Stanford by a guy named Eric Knudsen that showed that plasticity in the adult brain, any age, can be as robust as it is in childhood, as fast and as dramatic.
Wow.
Provided the focus is there, and it's all contingent on this acetylcholine molecule coming from nucleus basalis. So you say, well, how do you do that? How do you get it,
Exactly.
Well, I've got friends that chew Nicorette thinking that's going to get them there because Nicorette is a nicotinic acetylcholine agonist, but that's going to globally increase acetylcholine. So I always tell them that's not the right approach. The right approach is to bring as much focus to a behavior or to a thought or to an action pattern. And there has to be a sense of urgency. So what Knudsen lab showed, and another lab at UCSF, Mike Merzenich lab showed, is that if there's a serious contingency, like in order to get your ration of food each day, you have to learn this thing, the degree of plasticity is remarkable.
Right.
But if there isn't an incentive, it just isn't going to happen. So these circuits in the brain that Mother Nature set up are designed to be anchored to a real need. And people always say to me, well, should I do something out of love and a real desire to learn, or should it be out of fear? But either one works. The sense of urgency is just acetylcholine. It's norepinephrine. That's all it is. The brain doesn't have a recognition of whether or not something is pleasurable or not until later. Once you start accomplishing your goal, the reward systems like dopamine start kicking in. But I think if people are interested in modifying their brain for the better, at least some, top contour understanding of how urgency and focus must converge for that to happen can be useful, because I think there's a lot of attention paid to whether or not something feels like flow, or whether or not it's what I call highly desirable states,
right,
or whether or not you can eat a plant out of the ground that will magically put your brain into a state of plasticity. And the answer is yes, such plants exist, but what's missing is the focus component. If that work is not done with a particular end goal in mind, you'll get plasticity, but you'll get plasticity in a kind of across the board. It's like learning learning a little bit of 9 languages all at once is not going to make you speak coherently in any one of them.
Since 2023, I've partnered with On because I truly believe in the power of movement to bring us closer to ourselves, to others, and of course the planet we share. And what keeps impressing me is how this premium sportswear brand just continues to push innovation with this beautiful Swiss precision, and in ways that genuinely support you, whether you're logging big miles or simply just moving gently throughout your day. One of my favorite pieces is the Performance Tee. Now, it might look simple, but it is just packed with thoughtful design and cutting-edge tech that make a real difference when you're out there working hard. This tee features On's dry tech technology, super lightweight, quick drying, and breathable. The sweat wicking front keeps you dry, while the abrasion-proof fabric protects your skin even on the longest efforts. And the mesh panel in the back creates this steady flow of air that just keeps you cool and keeps things fresh. The smooth bonded hems and unnoticeable seams mean zero distractions. And the modern minimalist design holds it all together, complete with reflective elements that bring a clean, functional aesthetic that I just absolutely love. So head on over to on.com/richroll and explore the latest innovation in performance wear. This podcast, this one right here, is sponsored by Squarespace. Look, everybody's got a story to tell, experience earned on the field of life, gifts that are worth sharing, which is something I am consistently encouraging people to do, because when we do it, it turns strangers into friends and creates community where before there was none. To do this effectively, though, you need an online presence. It's just a fact. But even if you're building one from scratch or have an allergy to technology, there's really nothing to fear, because Squarespace's all-in-one platform makes the process incredibly simple. The newest feature is their Blueprint AI, which basically creates a custom website for you in just a few steps. You tell it about your industry, your goals, your personality, and it generates content and design recommendations that actually fit who you are. The world needs what you have to offer, but if people can't find you or easily work with you, it doesn't matter how good you are. So head on over to squarespace.com/richroll for a free trial. And when you're ready to launch, use code RICHROLL to save 10% off your first purchase of a website or domain.
Everybody talks about Alzheimer's and dementia as if it's a disease that just starts at one point.
Mm-hmm.
You are diagnosed with Alzheimer's disease. That's it. That's not the start. Right before that, decades earlier, there is a continuous cognitive decline that people experience. And, Dean and I go to different communities for talks, and before all this pandemic, when you go into a communities where, their health literacy is low, or for example, they haven't had any resources, you actually experience the cognitive decline when speaking with individuals in their 50s and 60s before they even are diagnosed with Alzheimer's disease. And it's scary, and the numbers are scary. And we never address that. And it's not just brain health. You hear about brain health all the time. You read great books, but it's that self that is under attack. It's that us. It's that usness. It's the sense of being aware and being present and being able to experience life. We're being robbed of that. You hear brain fog, you hear memory problems, but not being able to be present for each and every moment in your life, that's what's taken away from people. And that's scary. And if we have a way of making people attuned where we alarm them that, listen, there is something that you can do where you don't have to go through this, I think that would be a great opportunity. And it's a great gift for us to be able to serve people that way.
Right. So conventional medical wisdom, at least until recently, is or was that Alzheimer's is something that is going to be visited upon many, many people when they reach, late 60s, 70s, something like that. It's basically a genetic predisposition. In more cases than not, it's a death sentence. There's not much we can do about it. We can't cure it. We can't prevent it. We can kind of maybe manage it with some drugs, but really there isn't much that we can do. And we're working on a cure, but we aren't very close. So how much of that is accurate, and where does your work fit in to kind of upend that paradigm?
So the genetic component, let's start with that. We know the genes that are involved in Alzheimer's with new techniques like GWAS analysis and others, where you take large populations who have Alzheimer's and those that don't. You look at the genetic differences. We know about more than 30 genes that are involved in Alzheimer's. Of all Alzheimer's cases, the percentage that's driven by genes, 100% driven by genes, meaning that if they have these genes, they will get it. In genetic terms, it's called 100% penetrance, like Huntington's disease. If a person has the Huntington gene on that chromosome 4, they'll get it.
Right.
But the percentage of Alzheimer's cases that are like that is only up to 3%. The other 97% are affected by genes, but they are only risk genes, meaning that those genes increase your risk, but they're not a foregone conclusion. It doesn't mean that you will get it. The next highest risk gene is ApoE4. About 2% of the population has ApoE4, is ApoE4 positive. So if you have one of those genes coming from one parent, your risk goes up 4 times. If you have 2, one from each parent, about 12 times. That number varies, but roughly those are the numbers. So even if you have 2 genes fully loaded with these bad genes, 50% of people get the disease. The other 50% don't get it. Why? And when you look at the data coming from Nigeria, where the population had higher proclivity for ApoE, when they came to US, the disease went up. When you look at the studies that came from UK, which lifestyle increased your risk 6 times, even in lieu of ApoE4, you realize even with the higher genetic risk of ApoE4, lifestyle is a way bigger factor, by far. So all of the genes involved in Alzheimer's, except for those 3% or 3 genes, are all our lifestyle genes. How your lifestyle affects those genes, which means you have control over it. Even the most benign studies, the ones that had minimal effect, the MIND study and others. MIND study just looked at diet, very well done study. Just a diet adjustment reduced your risk of Alzheimer's by 53%.
Wow.
And that was a watered down version of the diet we think is optimal.
And how long would you need to be, eating in that certain way leading up to it? It
varies from person to person, their background, other things like if they had multiple head traumas, childbirth, like multiple variables. But in reality, if you're on that diet for several years, you continually reduce your risk. Like smoking, if you've smoked all your life, and if you come off of smoking, come off of that bacon, come off of that, then the more years you pass, I believe in smoking, it's after 5 years?
5 to 7 years,
5 to 7 years, you're back to baseline.
Right.
Meaning that you're back to the lowest risk factor. So the longer you stay on a healthy lifestyle, which is exercise and all the things that we say, and especially if you do all of them, the reason I say all of them, coming back to our grandparents, one of the elements is cognitive reserve, or what the term you and I love, idea density. You know, we say that if we have a musical band that's going to be called idea density. Yeah. They had idea density. Yes. It's a great concept. They both our grandparents had immense idea density and philosophers, thinkers, but they succumbed to Alzheimer's. Why? The other elements weren't taken care of. They had diabetes, cholesterol, high blood pressure,
quite
horrible
sedentary,
food.
bad food.
Didn't exercise. Philosophers are not supposed to exercise for some reason. But so you have to do all of it.
Right. So we're going to get into these lifestyle interventions. But before we do that, let's talk about the brain more generally. We sort of think of the brain as this mysterious black box that is unknowable and something that sits outside of our body, right? Like there's our body and then there's our brain, and these things don't really overlap. But in truth, brain health is really it's about vascular health in the same way that heart health is, right? Like we're dealing with, I don't know how many zillions of arteries that are going into the brain, putting things into your brain and taking them out, et cetera. And when you think about, heart disease, we all know we're trying to not have plaque in our arteries and keep those pipes running clean. And brain health is really not that different, is it?
That's very true. No, you put it beautifully. When you look at the brain, it's about 3 pounds, like Jell-O. It's like hard Jell-O when you hold it in your hands. And it's about 2% of your body's energy. And when you look at the tissues and the vessels, they're the same vessels that are in your heart and in your kidney and your body. I'm a vascular neurologist, so I teach a lot of anatomy to medical students and residents about the vasculature of the brain. But basically, you have arteries shooting from your heart going through the neck. There's 2 major ones in the front, the carotid arteries and the vertebral arteries. And these are the major vessels that take blood to your brain. And there's just branching of these arteries. And somebody actually calculated this, but if you put the vessels in your brain end to end, it would span about 400 miles. So just imagine all these tiny hairline arteries taking in oxygen and nutrients to these susceptible areas of the brain for this incredible organ to function. And at any moment, our brain, as little and as small as it is, it can consume up to 25% of the body's energy. So just imagine the amount of work that it does. And if we don't address vascular health, and if we don't really take care of it, it will succumb to disease. We always say, and our cardiologist friends don't really like that, but we say the rest of the body is there to carry the brain. It essentially comes down to the same pathological processes that affect the brain that also affects the heart, the kidneys, and the other systems as well.
In fact, recently there was a publication by Dr. Hitchinski from Canada, and he summarized the concepts, but the vascular factors actually predate, the popular thing that we hear, amyloid plaque and tangle. Vascular pathology predates those things. With the newer tools, with newer, more sophisticated MRIs, you can see 20 years earlier when somebody starts having some pathology. And the microvascular disease started way earlier. So if we take that into consideration, that in your 20s, 30s, 40s, the things you do isn't going to just avoid Alzheimer's. And we think absolutely for a great majority, 90% plus, you can avoid Alzheimer's. But more importantly, sustain cognitive capacity and grow cognitive capacity. We know that we don't use the full potential of the brain. In fact, as we get older, one of the areas that's affected the most is focus, for 2 reasons. One is the focus center shrinks, as well as the fact that we're overwhelmed. Multitasking, which we say there's no such thing as multitasking, it's doing multiple things badly. Right. It just accumulates and accumulates. But if you manage and control focus, you can actually grow your cognitive capacity as you get older. That's our goal, because if you do that, if we address the this is critical. If we address the vascular factors and the fact that we can grow the brain, we can hit all these communities that are now devastated with cognitive decline. And we see them all the time.
Right. So neuroplasticity then becomes a function of vascular health.
Absolutely.
Yeah.
Absolutely.
Super interesting. When we think of, again, back to the kind of heart analogy, we think of plaque buildup in terms of deteriorating heart health. With brain health, it's amyloid plaque, right? Which is different, but kind of the same, like it's blocking these passageways, and that's ultimately what leads to stroke.
Correct.
Is that right?
No, with stroke, it's atherosclerotic plaques. It's different. Amyloid actually accumulates outside of the neurons and stops the communication between the neurons. So it's a little different.
In between the neurons.
In between neurons.
Right, okay.
The neurofibrillary tangles, which is the tau, is inside the cells. There are two things happen. One is the amyloid plaques and the neurofibrillary tangles. They're connected in many ways. We are learning more and more. The neurofibrillary tangles are really interesting. There are these scaffoldings that hold the microtubules inside the cell steady. The microtubules are, it's almost like we just got the Oculus, and I was doing and it's a crazy thing. We were doing the roller coaster thing, and you see this roller coaster throughout the planet go, and the microtubules are these pipelines throughout the cell for transport, for structure, and everything. And the tau molecules hold them together. All of a sudden, they get phosphorylated and they come off, and then you see these scaffoldings fall apart and clog together. So for many years, we've thought that that's a separate process. It's a genetic proclivity, and there are those 3% variety. But we know that inflammation also attributes to that. Multiple traumas to the head, infections, multiple pathways to trauma, oral hygiene, and all of that, as well as vascular factors. So wait a second. So if vascular factors and inflammatory factors are contributing to even those tau and amyloid cofactors, we have control over those.
Right. Yeah. So that's amazing.
Yeah.
Like just the realization that we do have some domain over this thing that we've always kind of thought of as just looming out in the distance, and it's either going to happen or it's not going to happen.
Oh, absolutely.
Yeah.
Just understanding that our day-to-day habits affect those small little arteries in our brain. When you have sustained damage to the arteries, or sustained attack, let's just say, an attack to the system. So the body and the brain especially is constantly trying to revert any damage. We have damage control mode and we have a thrive mode. And the goal is to be more in the thrive mode rather than damage control. And the damage comes from, say, for example, vascular damage comes from sustained high blood pressure. Blood pressure is one of the most important risk factors for so many chronic diseases that we're dealing with. When we have uncontrolled blood pressure, the small blood vessels in our brains, they essentially collapse on themselves. And on MRIs, what we see is these patterns called white matter disease. White matter disease is when there's damage to the blood vessels. And so those parts of the brain are inflamed, or they don't really function very well. A lot of times they were called non-specific white matter disease, but we're actually learning more and more about them. And they have been correlated with cognitive decline. They've been correlated with strokes. And we know that lifestyle factors can really alter them, can change them. Diabetes is another risk factor. Damage to the inner linings of the arteries can cause damage. And, there are parts of the brain that require, all parts of the brain, but specifically the ones that are responsible for, say, for example, encoding memory, the hippocampi, or the frontal lobe where the judgment sits, or the emotion centers. When the blood vessels are damaged in these areas, we really can't function anymore. And that's when you see cognitive decline.
Well, let's talk about the neurochemistry of addiction. Walk me through what's happening in our brains and the role that dopamine plays in all of this.
Yeah. So dopamine is a neurotransmitter which means that it is the molecule that allows the electrical signal from the presynaptic neuron to be communicated to the postsynaptic neuron, because there's a little gap called the synapse between those two neurons. So neurotransmitters allow fine-tuning of those electrical signals. And dopamine is the most important neurotransmitter involved in motivation and reward. And the fundamental difference between things that are addictive and those that aren't is that things that are addictive release a lot more dopamine. So we have dopamine firing in our brain that occurs at a tonic baseline. And when we do something that's rewarding or pleasurable, we get a little rise in dopamine levels or a spike. So for example, chocolate increases dopamine levels about 50% above baseline. Sex is about 100%. Nicotine is about 150%. And things like methamphetamines are 1,000%. Mm-hmm. Partially because of their specific mechanism. But the fundamental way that I explain to patients and medical students, and now in my book, about the neuroscience of addiction so that they can really understand what's happening in the brain, is I say that really you have to imagine that in your brain there's a balance, like a teeter-totter in a playground. When we experience pleasure, the balance tips one way. When we experience pain, it tips the other. But one of the fundamental rules governing that balance is that it wants to remain level. So with any deviation from neutrality, the brain will work very hard to restore a level balance, or what's called homeostasis. Mm-hmm. So for example, if I do something pleasurable, like eat a piece of chocolate, I get a little tip to the side of pleasure, a little release of dopamine. But no sooner has that happened than my brain adapts to that phenomenon by downregulating my own dopamine receptors, downregulating my own dopamine transmission. And I imagine that is these little gremlins hopping on the pain side of the balance to bring it level again. Mm-hmm. Mm-hmm. But the thing about the gremlins is they like it on the balance, so they stay on until the balance is tipped an equal and opposite amount to the side of pain. And that's called the opponent process reaction, the hangover, the come down, the after effect. Now, and in my case, that's that moment of wanting another piece of chocolate. If I wait long enough, the gremlin hops off and balance is restored. But if I continue to consume chocolate in ever larger amounts to overcome the tolerance or the number of gremlins on the pain side, then I end up with enough gremlins on the pain side of my balance to fill this whole room. And I'm essentially in a dopamine deficit state with a balance tilted to the side of pain. Now I have to keep using, not to feel good, but just to feel normal. And when I stop using, my balance tips hard to the side of pain. I'm irritable, I'm depressed, I'm anxious, I can't sleep. Those are the universal symptoms of withdrawal from any addictive substance. And that can last a long time.
Back to the biochemistry of everything. Obviously, every substance has a different half-life, and the withdrawal from whatever you're doing is going to be different. But what's going on in your brain? You talked about the kind of seesaw and the way that dopamine operates. When somebody is withdrawing from a substance and they're kind of experiencing the pain that comes with that, what is going on, and what does it take to kind of get past that to the other side?
So there's a distinction between acute withdrawal and protracted withdrawal. Acute withdrawal is essentially where the body manifests the opposite of whatever the drug does. So if you have been using a stimulant, then in acute withdrawal, you will be sedated. If you've been using a sedative, then in acute withdrawal, you will have physiologic restlessness. And that can last anywhere between a few days to a few weeks, depending upon the substance and its half-life, as you point out. But once you get through the acute physiologic withdrawal, I think what's underappreciated generally is that there can be this sustained, protracted withdrawal that can go on for months and in some cases even years, which is primarily psychological symptoms. Again, irritability, anxiety, depression, and insomnia, as well as craving. So this is like ruminative, obsessive thinking about wanting to use. That can even be accompanied by sudden physiologic feelings, sweating, stomach cramps. But that's the piece that in my mind, I visualize the pleasure-pain balance chronically weighted to the side of pain because those neuroadaptation gremlins have essentially camped out there. They like it there and they're not getting off. And that is what drives relapse, even after people's lives have gotten objectively better, right? They've gotten their spouse back, their job back. And then people see them relapse and they say, well, why would they do that? Everything was going so well. But if you put yourself in the mind of that person, what you would see is that every day they get up, they are anxious, they are irritable, they are craving. And that is what drives relapse. It's sort of that intense physiologic and psychologic suffering, really.
Mm-hmm. Mm-hmm. Yeah, after the acute withdrawal, that protracted period where everything just feels gray.
Yes.
Because you're so used to those dopamine hits.
Yes.
And even though your life is getting better, in the back of your mind, you're just like, if I just do this one thing, like I'll be able to write that paper or get through this uncomfortable experience. And I'm just going to do it once. Mm-hmm. And that's the cunning, baffling, and powerful component here that mystifies the non-addict because it leaves them just, utterly confused as to why somebody would make that choice. But it's almost impossible to avoid.
Yes. Mm-hmm.
Depending upon the behavior and the substance. Obviously, some are more powerful
And what
than
I've
others.
come to appreciate is that something strange happens to our perception of time when we're in that state. So we're in that state of craving and dysphoria. It really feels like it will never end. I mean, it will. In most cases, we know with sustained abstinence, the gremlins hop off, homeostasis is restored. But when we are in that state, it feels as if it will go on forever. Plus, as you said, we have a way to fix it, right? It's right there within reach. If we use again, we can relieve those feelings. So I think that's the combination of those things, the distorted time perception that those awful feelings will never end, even though they will, and knowing that we can make ourselves feel better if we just use.
And if you're telling the patient they're facing the prospect of possibly years of this.
Right.
I mean, if they're coming off benzos or something like that, they're in for a very long, hard road.
Yes, that's right. Fortunately, in my experience, most people who abstain for 1 month begin to notice improvements in mood, hopefulness, sleep. They might not be where they want to be, but they begin to see a little bit of light at the end of the tunnel. Not always, but that's the piece that then I really have to remind them of. And I say, remember how you felt when, and if you can just hang in there with recovery and with abstinence, incrementally in small ways, you will get better. And I think that's an important function that I serve, kind of a cheerleader and a reminder, because the hippocampus is tricky. I also think that's a major function of AA, right? That we go, I use the we pronoun. So I'm not a member of AA, but I in my clinical work, I use the we pronoun because, again, I think we're all broken and humbled in the face of this problem. So I'll say to patients, remember how you felt then. Remember how you felt a little bit better. You've done this before. You remember, you have the data from recovery. Hold that close. And tincture of time alone will get you there.
Are there cases where that dopamine balance never again reaches some level of homeostasis?
Yeah, so unfortunately, I think that can happen. Yeah. So, for example, in the book, that I think the case of Chris, possibly one of the things that happened to him was after so many years of opioids and heroin, that the only way that his balance was essentially broken, it was stuck, tilted to the side of pain, and the only way for him to feel normal is to be on, what's called replacement therapy or opioid agonist therapy in the form of Suboxone, which has sustained him feeling well, now going on almost a decade. And I'm talking very, he's doing great. It's not like he's just kind of trudging along. He's doing great.
And he's been able to maintain that level of Suboxone at a base rate. Like he's not asking for more.
No. And I do see that. I do have patients for whom, for reasons we don't understand, they do seem to develop tolerance, but not him. It worked immediately. It worked well. It restored homeostasis. He's re-engaged with life. And he's interestingly somebody who never went to 12-step and never really got a whole lot of psychotherapy beyond, what we do. But that's what works for him.
Yeah, it's so interesting. I'm in the process of recovering from a pretty major surgery, and this has left me thinking a lot about legacy. The relationship between what we do now and what we're actually leaving behind for future generations. Well, my friend RJ, who founded and runs Rivian, thinks about this constantly. Sure, he builds electric vehicles for all kinds of adventures, and amazing ones at that. His mission, however, is way bigger than that. A mission that is informed by asking a pretty deep question, which is, how do we keep the world adventurous forever? Adventure is only possible with a thriving planet. You can't have one without the other. Sustainability and adventure, these are not opposing forces. They're simpatico, they're partners. Every generation deserves wild places to roam, to climb higher, to be transformed by the journey. But that only happens if we're designing for a future where exploration doesn't come at the expense of nature, but actually inspires us to protect it. And it's for all these reasons that I'm just so thrilled and honored to join forces with Rivian, to partner with them in support of building the momentum they have already created to move toward a more optimistic, regenerative future. As a very proud Gen X elder, caring about skincare has always been basically like something that was just off the table. But listen, times change. I've certainly changed enough at least to understand how ridiculous it is to not care about my largest organ and actually be proactive about supporting it. I don't have time for elaborate routines between the podcast, family, everything else I'm doing. I really need something simple, something convenient, and most importantly, something that is evidence-based and actually works, all of which led me to Bon Charge, which is a company that builds science-backed wellness solutions that fit your life. My personal favorite is their red light face mask. This has become part of my daily routine. It's award-winning, it's lightweight, flexible, and contours to your face perfectly. Since using it, I think my skin looks a bit better, more smoother, just healthier overall. Plus, secretly, it's pretty fun to wear. It's also rechargeable and works for all skin types. So go to boncharge.com and use coupon code RICHROLL to save 15%. What if I told you that all humans, all of us, are equipped with this innate capacity for spirituality? Maybe you can wrap your head around that, but here's the kicker. Now, hard science, I'm talking about neuroscience, actually proves that cultivating spirituality, what today's guest calls the awakened brain, leads to things like greater grit, greater optimism, greater resilience, and conversely insulates us against things like addiction, trauma, and depression. Okay. I want to talk about the areas of the brain that get lit up or that get turned off and all of that. First of all, like constructing the study, like how do you come up with what the study is going to be, and then you're putting people into the fMRIs. We should talk about what an fMRI is and what it can tell us, and what you discover about these different areas of the brain and how they're impacted by cultivating the awakened mind, the awakened brain.
That is an elegant way to ask the question, and I can't wait to respond to it. Okay. So using the lens of epidemiology, it was clear that those threads of lived human spirituality, which are protective against addiction, which are part of our strengthening and deepening in the path of recovery and renewal from trauma or depression, were this sense of transcendent relationship, right? The capacity to perceive transcendent relationship, and that might be shared. Okay? So knowing that through the lens of epidemiology, there was something heritable built into us, a form of spiritual awareness that had such a huge impact on our health and wellness, it seemed that we could try to operationalize that dimension as a task in the MRI scanner and live action, watch people engaged in a deep transcendent relationship. So that's what we did. We sat around the table for 18 months and used previously validated ways of working in MRI studies to come up with an in-scanner task that represented that thread that had been identified over 10 years of epidemiological work. And here's how we worked. Together, Spirituality Mind Body Institute, my institute, together with Mark Potenza and Rajita Sin at Yale, together literally for a year. We sat around and figured out the method, and then for another 6 months, operationalized it. And here's how we did it.
18 months just to devise the experiment.
Yes, because the most meaningful part of a research study is the question and its method, right? This had never been done before. And in fact, scientists had said, you can't operationalize spirituality. It's too broad and vast. And that's where using multiple levels of inquiry, bringing a finding from epidemiology into an MRI scanner allowed us to make progress, as well as working between labs. You know, the Manhattan Project didn't have one guy or one woman's lab.
Sure.
It's collaboration. So Rajita Sin had found over 15 years that when we tell a story, a memory, in a way that's very palpable and rich and has lots of sensory points, real anchors in it that bring us back in time, we elicit the same neural correlates as if we were there, plus memory. Right? And Mark Potenza, working with Rajita Sin, had become one of the leading experts around addiction. And he had found that the addiction loop in our brain, the insulin striatum, is the same whether we are addicted to alcohol and drugs or pornography and the internet or gambling. It's the same. I've got to have it, right?
Mm-hmm.
So they had worked together, Rajita and Mark, in the past, developing this in-scanner task when it came to craving, when it came to telling stories of addiction, hungry, and I need to have the drug, I need to have, I've got to get to Vegas, I've got to have this, roll of the dice. Well, when I approached them, I said, we know from epidemiology that there's nothing as protective against addiction as a strong personal spirituality. Can we watch that in the scanner? And of course, as open-minded creative scientists, Mark and Rajita were thrilled. We sat down for a year and a half, and we took the following question after a year and a half of inquiry to 18 through 25-year-olds. We said, tell us a time when you felt a deep connection with your higher power. Some people say God, Jesus, Allah, Hashem. Some people say the universe or a oneness with all life. But tell us a time where you felt a deep connection with a deeper, deeper presence of life that was loving and guiding. Nobody was confused. 18 through 25-year-olds in New Haven. A lot of them were Yale students. A lot of them were agnostic, some spiritual but not religious, some not friendly to the whole idea of religion. Nobody was surprised. Everyone had an important experience. Everyone.
And how many people? What was the population size?
Well, okay, so in order to, in MRI studies, there's often very small samples, and you can publish a study with like 10. But we had about 30 people who went through every phase of this study. Right? And in this study, whether they were Christian, Catholic, Jewish, Muslim, Hindu, spiritual but not religious, no matter what their background was, the same neural correlates ran as they told us that narrative.
And what is a neurocorrelate?
So as we wanted to be very precise, we literally knew at what point in their study they felt this unitive experience. So we had them tell their stories. This is part of Rajita Sin's method over 15 years. Tell the story, tell it again while it's audio taped, play it back in earbuds in the MRI machine while the fMRI is running, so that we can pinpoint to the T what neural correlates are seen, what happens in the MRI as you say this specific little passage in your story. And right at the point where the young adults would say, I'm walking down the street, I'm completely depressed, I've just been turned down at 5 out of 6 medical schools, I'm such a loser, I'm never going to be a doctor like my mother. But then suddenly I see light in the leaves. And I know that God has a plan for me. Or suddenly I see light in the leaves, and I know that life is buoyant, and I will be a healer in the way I am intended. Or suddenly I see light in the leaves, and I know that there's a path for me greater than anything I know yet. That aha, the reshuffling of meaning that is illuminated and speaks to a true part of myself. Right as that part of the narrative is told, we saw coming up online 4 major components of what we're calling the awakened brain. The first is that quieting, I'm such a loser, quieting the racket. The default mode is powered down. Now that you can do through mindfulness. That's simply getting present.
That's the network of rumination.
Exactly.
Right.
Now, very often, because we have a hungry culture Many people are taught mindfulness to get present, and it's helpful, but it only stops there. It only gets us present. When in fact, what then is potentiated is that we are at a threshold to cross for being present into a state of awakened awareness. It's mindfulness plus. It's crossing into, and the next three loops are first and foremost, just as we were held as children in our parents' or grandparents' arms, we feel loved, we feel held, the bonding network is engaged, and we are aware that life itself is holding. The next is the parietal.
That's the frontotemporal network.
Yes, exactly. Right.
Yeah.
So that was that was the article. And in fact, I'll tell the whole story. Then the next piece to come online is the parietal. It puts in and out hard boundaries. So just as there's a sense of discrete and specific experiences, you have your path, you live in California, you have your family, you look like you, and I live in Connecticut and I have my family. We are distinct, we are magnificently diverse, we are different. And at the same time, there's a deep common unit of experience, a common human heart. The parietal puts in and out hard boundaries so that we can toggle between a sense of difference and common love, common felt being. And then the final piece, which is
But just to put a finer point on that, reduced activity in the parietal lobe allows the influx of this sense of commonality among all. Is that right?
Yes.
Is that fair?
That we are connected.
Right.
Or one. Exactly. And then finally, this is a particular importance to innovation, to decision-making. The Army's really championed this dimension of awakened awareness. We move from a narrow top-down dorsal attention network. Tactical, strategical. We've got to get out the red door. We've planned, we're prepared, everybody's trained, we're going out the red door. But today, here live, the red door's jammed. We can't get out. That's a metaphor, of course, for life. Everything was in the bag. A plus B plus C. Of course, it was me who was going to be promoted. And then they brought in somebody? Right? Or A plus B plus C. I was the one, it was my turn to be quarterback. It was my turn to be on the varsity football team. And what? I got cut? So it all didn't add up. The red door stuck. And because the red door stuck, we shift in a state of awakened awareness from the top-down, narrow, bowling alley perception of the dorsal to the bottom-up ventral attention network. We have a much broader field of perception, far more information. And many people say that the right answer, the new possibility, pops. The yellow door. Never would have seen the yellow door. But the yellow door leads to a landscape that was surprising, that could be magnificently, in the big sense of the word, prosperous. I meet the person who I am best friends with the rest of my life. I find a line of work I never dreamed of. I end up in a city that was so very much at home. The yellow door opens, and that possibility of bottom-up perception leads to a form of creativity and innovation the Army calls situational awareness.
Right.
That allows us to align with the way life really is.
You can see the whole chessboard as opposed to the one piece that, you can't move the way that you want it to move.
Yes, and your opponent played something you never dreamed based on the books he'd play. Right. That's why it's harder to play a bad opponent than a good one, right? But that's the real chessboard that's actually here now. And when we have actual alignment with what is life showing me now? What is the chessboard actually telling me now? We're able to make much better decisions. So how do we put the spiritual core back in? Well, if it's a public school or the public square, it's minus religion. That can happen at home, but spirituality exists independent of religion. And how can we do that? Again, at home, the religious embrace of spiritual awareness is important for many families. Roll with it. Do that at home. But in a public school, we can strengthen the muscle of transcendent awareness of spiritual values towards one another. And in fact, when we look in the MRIs at the neural correlates of the awakened brain, of all forms of spiritual practice, that which most correlates with a strong spiritual awareness is love of neighbor. Love of neighbor and service, altruism. That can be part of every classroom. Circle time, whether we're 5 years old or sophomore year by the locker. Of all people on earth, you were put next to your classmate who struggles with low EQ. Your classmate doesn't really know how to talk to people. Your classmate maybe is a little awkward. Were you put there to bully her and make her feel horrible? Or were you put there perhaps as some form of inspiration or guide Might you even be what I call a trail angel for her? We can recast who we are to each other as helpers and healers. Love, guided, held, and never alone. Can we show up that way for one another? And that can be taught in school. But the other things that need to be taught that are part of our natural awakened awareness are listening to our inner wisdom as hard data. And we need to reboot our capacity for transcendent awareness in a way that is inclusive, certainly constitutional, and in the language of life. And there are practices in the awakened brain for reawakening our brain, but we could do one if you want to do one.
Yeah, we can do it.
You want to do it? Great.
Yeah.
Okay. This one I want to honor my teachers, as I think, is in many traditions. This was taught to me by the late Gary Weaver, and I've done this exercise with thousands of people, none of whom have ever felt offended because it's in the language of life. Yeah. And I do this with the U.S. Army, and I do this with people on Wall Street, and I do this in homeless shelters. I do this everywhere. Yeah.
All right, let's do it.
Let's do it. Okay. I'm going to invite you to clear out your inner space, 5 breaths, and then we'll do about a 90-second visualization. 5 breaths. I invite you to set before you a table. This is your table. And to your table, you may invite anyone, living or deceased, who truly has your best interest in mind. Anybody living or deceased who truly has your best interest in mind. And with them all sitting there, ask them if they love you. And now you may invite your higher self, your true, eternal higher self, the part of you that's much more than anything you've done or not done, anything that you have or don't have, your true higher self, and ask you if you love you. And now finally, you may invite your higher power, whatever word that may be, however you know, your higher power. And ask your higher power if they love you. And now with all of those people sitting there right now, what do they need to share? What do they need to let you know? What do you need to know right now? And when you're ready, I invite you back. This is your counsel, and they're always there for you. Who shows up may change depending on where you are in your road of life. And you can ask them different questions depending on where you are in your road of life. But your higher self, your higher power, and those who truly have your best interest in mind, this is a form of deep awakened awareness. This is the deep loving consciousness that flows in and between us and through us. And we are built to be able to see and know this level of love and relationship.
You mentioned the mind-body connection, and I think that's a really important point in broadening our understanding of this world of hypnosis.
Well, you mentioned snake oil earlier, and one of the things that really troubles me, saddens me about the way hypnosis has been understood and treated is, there have been a lot of problems with medications too. We have 60,000 opioid overdose deaths in the United States last year. Medications have their problems too. And I'm a physician, I use medications. I'm not against that. But, the major evolutionary advantage we have as humans is this big brain on the top of our bodies. It's connected to every organ in the body. But it doesn't come with a user's manual, and so we don't take full advantage of what it can do. And we underestimate. We tend to think that the real treatments in medicine are ingestion, injection, or incision. You know, that the body is like a broken car. You just replace the part and everything will be fine. And otherwise, you're not really doing anything. You're just talking to the person. And I'll tell you, Rich, the day that that turned me around about this, I was a third-year medical student at Harvard. I was in pediatric rotation. The nurse says to me, "Spiegel, your next patient is in room 342, and I'm following the sound of the wheezing down the hall. And there's this 15-year-old girl, redhead, bolt upright, knuckles white, struggling for breath. You could hear the wheezing. Her mother's standing there crying. They had tried to use subcutaneous epinephrine twice. It didn't work. They were thinking about general anesthesia and starting her on steroids. And I didn't know what else to do. So I said, you want to learn a breathing exercise? And she nods. And I had started a hypnosis course. And so I got her hypnotized. And then I realized we hadn't gotten to asthma in the course yet. Mm-hmm. So I came up with a very clever idea. I said, each breath you take will be a little deeper and a little easier. And within 5 minutes, she's lying back in bed. Her knuckles aren't white. Her mother's not crying. And she's breathing almost normally. And the nurse ran out of the room. My intern comes to find me, and I figure he's going to pat me on the back and say, "Good job, Spiegel. What'd you do?" You know, he said, "The nurse filed a complaint with the nursing supervisor that you violated Massachusetts law by hypnotizing a minor without parental consent." And, you know, Massachusetts has a lot of weird laws, but that's not on the list. And her mother was standing next to me when I did it. So he says to me, "You're going to have to stop doing it." And so, I mean, just observing that, I think, you know, there is something here. There's something to this. The brain can really control what's going on in the body, even in rather extreme circumstances. So they told me that it was dangerous. And I said, "You're going to put her on steroids and put her under general anesthesia, and my talking to her is dangerous, you know?" And he said, "Well, you may not be able to follow her." And I said, "Well, I'm in Boston. I'll follow her as long as it's necessary." And he said, "You got to stop doing it." I said, "I'll tell you what, as long as she's my patient, I'm not going to tell her anything I know is not true. So if you want to take me off the case, go ahead. But otherwise, I'm not." So there was a council of war among my intern, the resident, the chief resident, and the attending that weekend. And they came back on Monday with a radical idea, never been tried before. They said, "Let's ask the patient." And she said, "I like this, you know." And that observation, that just something I said to her, that using this simple, straightforward, undangerous technique could produce such a radical change in such a short time, really hooked me. I mean, I'd learned a fair amount about hypnosis growing up, but nothing like this, where you see it happen. And that, I think, is one of the tremendous advantages right now, is that you will know very quickly whether it's going to help you or not. It doesn't help everybody, but it helps a lot of people. And you can feel it right away, which is unusual among psychotherapies, even among medications. It often takes a while to feel the effects.
And what do we know and perhaps have yet to learn about what's going on neurochemically in the brain when you induce a hypnotic state? Like, what aspects of the brain are being turned on, turned off, et cetera? We've
been studying that for the past decade, and we've discovered some things that really begin to make a lot of sense. And one of them is, I'll talk first about neural function in the brain and then neurochemistry. One of the things that happens when somebody goes into a hypnotic state is that they turn down activity in the dorsal anterior cingulate, the salience network. The way to think about the cingulate gyrus is it's a bundle of nerves that looks like a C on its end here, and it goes under the cerebral cortex and over the limbic system. And this part here in the front, the dorsal anterior cingulate cortex, is part of the salience network. It's part of the brain that is a context detector, and it tells you, should I pay attention or not? And so if a loud noise suddenly happens, you startle and you go turn your attention to where it is. Social media is very good at using this. You know, they'll float something by you that sounds a little scary or threatening, and you suddenly, detach from what you were paying attention to. That's the salience network. In hypnosis, you turn down activity in that brain region. And in fact, in another study, we looked at the prevalence of neurotransmitter activity in those regions, and you see more GABA activity in the anterior cingulate of people who are very hypnotizable. So they have more ability to inhibit. It's an inhibitory neurotransmitter. It's one that is activated by anti-anxiety drugs. And there's greater ability there because of the higher prevalence of this inhibitory neurotransmitter to inhibit the salience activity. So it's one thing that helps you concentrate intently. You're less likely to worry about what else you might be thinking of or thinking about. The second thing that happens is higher what we call functional connectivity. That's if one region is active, the other region is active, that region is inactive, the other region tends to be inactive. Between the dorsolateral prefrontal cortex on the left, which is part of the executive control network, it's the part of my brain I'm hopefully using now as I'm describing this to you, and the insula, that's another part of the salience network that's a major mind-body pathway. So it helps your brain control what's happening in your body, control gastrointestinal function, control autonomic activity. And so you have a greater ability in hypnosis to control what's happening in your body, like that 15-year-old girl with her asthma attack.
Right.
The third thing that happens is you have inverse functional connectivity. So when one region's active, the other is inactive between the executive control network and the posterior part of the cingulate cortex. That's what we have called the default mode network, and it's a part of the brain that's active when you're thinking about yourself, when you're reflecting on who you are and what it means. It's a part of the brains where activity goes down in experienced meditators. And of course, part of meditation is to sort of detach from your selfness, to just experience things and not judge them or see what they mean for you. And that's a mechanism of dissociation in hypnosis. So we found that a lot of things that we know from the phenomenology of hypnosis are actually happening in specific regions of the brain that should control that kind of activity.
And is this the result of fMRI testing that you've been able to discern all of this?
Yeah, we've screened hundreds and hundreds of thankfully cooperative Stanford students and picked out the ones who on formal testing are very high and very low in hypnotizability. We put them in the scanner, the highs and the lows. We give them hypnotic instructions, and we see what happens in the brains only of the high hypnotizables and only when they're in the hypnotic conditions. And that's what enabled us to observe what's going on in the brain.
And on that subject of hypnotizability, let's talk a little bit more about that. I mean, first, how do you determine whether somebody has a high receptivity to it? And secondarily to that, is that sort of a preset that people come into the world with? Is it malleable? Is it something that can be shifted with technique?
We're doing some research now that adds to another body of research over the last decade or so, showing that there does seem to be a genetic component to hypnotizability, that particularly people with a certain polymorphism of the production of dopamine, a neurotransmitter that's prominent in the prefrontal cortex and throughout the brain. If they produce just enough, so this is an enzyme, catechol-O-methyltransferase. It's an enzyme that metabolizes dopamine. And if you're at a point where you don't metabolize it too quickly or too slowly, those people seem to be more highly hypnotizable. And related people with, in general, genetic commonalities, tend to be more similarly hypnotizable than people who are unrelated. And so there is some evidence that it may have to do with this genetic variation in neurotransmitter metabolism. But there's also evidence, Josephine Hilgard published a book called Personality and Hypnosis, where she looked at the early life histories of former Stanford students and found that higher hypnotizability was associated with one positive and one negative thing. Imaginative involvements. Children who had been raised to have imaginative involvements. Their parents read stories to them every night. They played games in their imagination, turn out to be more highly hypnotizable. But sadly, also children who have been physically and sexually abused are more highly hypnotizable. And it may be that it's a kind of protective defense mechanism if you're going through terrible experience. So
because they developed the ability to disassociate when their brain was still malleable.
That's exactly right. I had one patient who said, I'd just go to a mountain meadow full of wildflowers when my father and his friends were abusing me. That's the way she dealt with it. And so there's a developmental part of it, but the other part of the story is that most children are highly hypnotizable.
Right. That's what I was thinking,
Yeah.
because they're less calcified in their neuro pathways.
That's part of it. And because for children, knowledge and emotion and experience are all kind of one thing. It's why work is play for kids. It's a shame that we make them into little adults because they love doing whatever it is they're doing. They just get fully engaged hypnotically in a way in whatever they're doing. And you call your 8-year-old in for dinner and she doesn't hear you. She's out doing whatever she does. In adolescence, when we develop what the psychologist Piaget used to call formal operations, where you kind of privilege logic over experience, many people lose to some degree that hypnotizability. And by the time you're 20, 21, the level you have is what you're going to have 25 years later. And they did a study at Stanford in which they blindly retested students and at 25 years after they'd taken their Psych 1 class, and found that there was a 0.7 correlation between their original hypnotizability and the one they had at age 45 or 46.
Is that Zimbardo?
Yeah,
that
that's
did that?
Phil Zimbardo.
Yeah.
Yep.
I took Psych 1 from him.
Did you really?
I was not part of that cohort.
You weren't part of
though.
that cohort? Did
No.
he read his
I mean, it was
hypnotic susceptibility
30 years
scale?
ago. I don't remember.
Yes, that's right. You were there in the 80s. You were at Stanford. Well, so what it suggests is that once you get into early adulthood, it's a very stable trait. It just doesn't change very much. And so some people who retain it, I think, have brains that have been have grown into a relationship, particularly between, and we've done some neuroimaging on this too, the dorsolateral prefrontal cortex and the anterior cingulate. And the students we studied who were more highly hypnotizable had more functional connectivity between the executive control and the salience networks than the low hypnotizables. So when they thought about something, they tended to coordinate that with the part of the brain that says, is this worth thinking about or not? Whereas, and it's interesting, if you see really low hypnotizable people as adults, and I see a lot of them, they come to me, they want to be hypnotized, and they're not hypnotizable. They're very critical and they evaluate things carefully, and they argue and they raise questions, which is all good, but it's a kind of non-hypnotic way of responding.
Right.